Hey everyone, welcome to this explainer. Look, if you're laser focused on building better data systems, but you're just tired, tired of that endless battle with infrastructure bloat, well, you're in the exact right place. Today, we're unpacking a massive paradigm shift in data architecture that we recently found in materials from Datatism. We're talking about Duck Lake. It's this incredibly elegant new approach in the data engineering space that is taking the monster of infrastructure complexity head on. It basically proves you absolutely do not always need some massive, convoluted distributed system just to get top-tier analytical performance. All right, let's get into it. So here is our roadmap for today. First, we'll look at the modern lakehouse problem. Then enter Duck Lake and relational metadata. After that, solving the small file problem, distributed versus single-node architectures, AI and semantic metadata, and finally, why the future is simple. Now, I want to kick things off with a question that I'm sure has kept more than a few of you up at night. Why on earth do we spend more time managing our data infrastructure than actually analyzing the data? It is a massive pain point. Just think about the exhausting amount of time your data teams spend wrestling with cloud credentials, tracking down missing jar files, which, let's get real, is basically a developer's root canal, and managing distributed orchestration, literally just to keep the lights on. It's incredibly frustrating when your actual goal is to extract business value, but you end up stuck playing the role of an infrastructure plumber. Section 1, the modern lakehouse problem. So, modern data lakehouses are great, right? They brilliantly gave us the economics of cloud storage. But the source material points out a fatal flaw when it comes to scaling, and that is a growing hierarchy of small metadata files scattered all across object storage. To really visualize why this is such a nightmare, imagine walking into a massive, beautiful library, but instead of a sleek, organized digital catalog, finding your book means you have to read through literally millions of loose index cards scattered all over the floor. Every single time someone asks, hey, what did this table look like 3 days ago? The query engine has to sweep that floor, inspecting metadata files, resolving snapshots, and trying to reconstruct the table state. Object stores are absolutely amazing for durable data, but they are definitely not built to be relational metadata engines. Because of this scattered index card approach, you inevitably hit a brick wall of performance issues. Object store API calls spike through the roof. Network latency really starts to drag. And you face these incredibly heavy file listing operations just to figure out what data is actually valid. All of this leads to higher metadata planning overhead, agonizingly slow transaction commits, and a way higher risk of write conflicts. The core issue boils down to this: trying to resolve complex transactional relationships across thousands of small files in an object store is just fundamentally inefficient. Section 2. Enter Duck Lake and the shift to relational metadata. When we look at these two approaches side by side, it's a modest but incredibly powerful shift. On one side, your traditional lakehouse relies entirely on object storage for both those large data files and the complex metadata files. But with Duck Lake, you keep the analytical data files, like your big Parquet files, in object storage while moving all of that lakehouse metadata into a lightning-fast relational SQL database. So suddenly, metadata resolution isn't this massive object store traversal problem anymore. It just becomes a simple, highly indexed database operation. Think about traditional distributed setups. They're usually a total clutter of Spark configurations, making sure you have the exact right Java versions, Hadoop libraries, dealing with those missing jar files and catalog misconfigurations. Honestly, it can take days just to get a stable environment running. Duck Lake setup? It is literally 2 lines of code: install Duck Lake and load Duck Lake. That's the whole shebang. It's almost shocking how much infrastructure is just stripped away so you can actually start building right out of the gate. Section 3. Solving the small file problem. To tackle one of the biggest headaches in data engineering, Duck Lake introduces a really clever mechanism called inlining. Inlining is essentially a built-in buffer for those high-frequency micro-batch writes that typically just clutter up your storage. So instead of immediately writing every tiny insert into a brand new, wildly inefficient Parquet file in your object store, Duck Lake temporarily stores those small amounts of data directly within its relational catalog. Let's walk through the journey of a single, tiny data insert just trying to find a home. Step 1, the small insert arrives. Maybe it's a single application log or a quick IoT message. Step 2, instead of kicking off some massive file creation process, that data is stored durably and safely right there in the catalog. Step 3, it just hangs out, accumulating with other small incoming rows over time. And finally, step 4, once a specific configured threshold is reached, all those accumulated rows are flushed together into a single, perfectly optimized large Parquet file. It beautifully bridges the gap between high-frequency writes and analytical efficiency, all without you having to manually run those complex, painful compaction jobs. The really crucial takeaway here is how this metadata structure just completely supercharges your query execution. Because the metadata is relational, Duck Lake uses indexed SQL to instantly pinpoint the correct snapshot. It literally ignores invalid files before they're even touched. It zeroes in on only the exact required data and then feeds it into a high-performance execution engine. The efficiency gains you get here are just absolutely massive.
Section 4. Distributed versus single node.
The source material poses a really fascinating question that I think we all need to answer honestly for our own organizations. Does your workload genuinely require a distributed, multi-node execution model? For years, the industry just assumed that analytical systems had to be distributed, right? Mostly because storage was slow and memory was super limited. But today, modern single machines come with blazingly fast local SSDs, massive memory bandwidth, and incredible multi-core parallelism. When we map out a pragmatic decision pattern, the boundaries become really clear. Single-node architectures like Duck Lake are absolute powerhouses for things like embedded analytics, SaaS telemetry, rapid application development, and departmental lakehouses. Think about it. Most business queries just select a subset of columns, filter by a date, and aggregate. A single node handles this beautifully, and it can even spill over to disk if memory runs out. On the flip side, if you are tackling large-scale fraud detection, global internet-scale telemetry, or massive machine learning training, you definitely need distributed complexity. But the real takeaway? Only introduce distributed complexity when it is strictly, undeniably justified by the workload.
Section 5. AI and semantic metadata.
One of the most exciting implications of moving your metadata into a relational catalog is the creation of a true semantic layer. In this setup, annotations aren't just passive, boring documentation meant for humans to read. In Duck Lake, your catalog becomes a dynamic semantic control plane. This means you can define fiscal rules, confidentiality classifications, and core business logic directly alongside the data. You're turning passive notes into active, machine-readable guardrails. And what's really amazing is how this setup is exactly what AI coding agents need to thrive. By completely stripping away the clutter of distributed infrastructure, AI agents can effortlessly inspect that relational metadata. They can instantly infer schemas, generate analytical views, and understand exactly what data is safe for external reporting based on your semantic rules. Because there are no messy Spark configurations or missing jars to trip them up, these AI agents can just inspect the metadata and produce reliable, deterministic code. This kind of simplicity is basically an incredible architectural leverage point for AI.
Section 6. The future is simple.
Just look at this number for a second. 50%. In a lot of enterprises, data teams waste over half of their time just keeping the infrastructure lights on. Think about that. Provisioning databases, configuring networking, resolving package versions, none of that actually creates any business insight. Duck Lake's real strategic value lies in reversing this ratio. It allows engineers to actually spend their time understanding business requirements and building data products that drive real decisions. There's this great quote from the source material that I think captures the core philosophy of pragmatic architecture leadership perfectly. It says, use the simplest technology that reliably solves the problem and can be supported by the organization. Honestly, a technically impressive, massive distributed solution is actually a terrible enterprise decision if only 3 highly specialized people in your entire company know how to maintain it. To wrap up this new architectural pattern we've been exploring today, it is really all about empowerment. You want to emphasize strong single-node performance. Keep your data in open file formats like Parquet to avoid vendor lock-in. Leverage relational SQL metadata for lightning-fast cataloging and inlining. Enable local-first development so your team can iterate rapidly. And above all else, only introduce the heavy burden of distributed complexity when it is absolutely required. I'm going to leave you with one final, pretty provocative thought to ponder as you look at your own organization's architecture. Are you truly building for scale, or are you just building complexity? I really hope this explainer has given you the insights you need to rethink your data strategy and start embracing the power of simplicity. Thanks so much for learning with us today, and we'll see you next time.